So much. I'm delighted to be here. I think this is engagement 14 or 15. So they've thrown me everywhere. I've been in a film class. I've been at the Center for Healthy Minds. And it's been so delightful to be on a campus that really seems to understand the relationship between art and science as something really essential. And in fact, I've had a lot of meetings with science professors who say, let's meet, let's talk. I really need help communicating the science I'm doing. And I think there's a growing recognition that you can be doing incredible research and finding incredible data that can really help people. But if you can't get that out to the public in a way that people can understand, then what? You know, it's very frustrating. And I think most scientists I've met with, so I've been working with neuroscientists for 13 years now, and we seem to understand that actually what we're doing, what I'm doing as an artist, and what they're doing as a scientist is actually very similar. We're asking questions, specifically for me, I'm asking questions about how memory works, and they're asking the same questions. And I really think it's the general public that thinks that artists and scientists are diametrically opposed. But in my relationship with scientists, we feel like we're like two peas in a pod. And the really interesting thing is most of the neuroscientists I work with and many of the neuroscientists I've met are actually artists as well. Many of them are musicians. In fact, a couple of very well-known neuroscientists, Daniela Schiller's in my film, we're only going to see a very small excerpt, so you might not get to see her. She's in a band. She's a drummer in a band called the Amygdalas. And it's all neuroscientists, but I go see her play in New York City all the time. And in fact, I did a similar residency at UCLA Semel Institute, and at a big event they also had a band that was made entirely out of neuroscientists. So I definitely think there's something going on there, and we just need everyone else to get on board with us, right? About the intimate relationship between art and science. So that's what we're going to talk about today. We're going to talk about, I'm not going to go deep into explaining the neuroscience. I know some of you are science students, some of you are media, communication, art students. I'll give you a very general overview of the kind of neuroscience I have been exploring in this particular film, which you'll see a 5-minute excerpt of. So I'm not going to explain the neuroscience. What I really want to do is talk about how we take complex ideas and make them into something people can actually feel. So out of the diagrams and the charts into an experience of it that makes people appreciate that actually science has a great impact on our most intimate parts of our lives. In the realm of memory, which I explore, there are so many people struggling with PTSD. There are people struggling from memory loss, and then there are just people who might not be on either end of that spectrum, but just might be haunted by a memory, or may have memories that are keeping them in a box and that they need to reframe. So just broad strokes. What I explore is the science of memory reconsolidation. Does anyone know what that is? Want to hazard a guess? Okay, so the science of memory reconsolidation was discovered in 2000, and before the discovery, it was believed that once you stored a memory, once you created a long-term memory, that memory would never change. So once you stored a memory, every time you recalled it, it was the exact same memory. It was almost like a recording, and that it was entirely accurate. A neuroscientist, actually a PhD student at the time at NYU, had the thought, wait, why wouldn't your brain go through the same process involved in consolidation, which is, a neuron connecting to another neuron with a synapse, that's the formation of a memory, every time you store a memory. And he did an experiment, and what he discovered is that every time you recall a memory, you go through the process of storing it as if it is a brand new memory. So has anyone here heard of the film The Eternal Sunshine of the Spotless Mind? Okay, so that's based on this study. So we look at that film, and when I saw it as well, I thought this is science fiction. But no, he showed you can actually erase a memory. So let me explain how that works. Here you can see, this is actually stop motion animation. It's a still, but these are essentially synapses connecting to neurons. This is what it looks like when your brain is firing and creating memories. And what he showed was, very simply, they create a fear memory in lab rats. And the way they do that is they expose the rat to a sound. And at the same time they expose the rat to a sound, they give the rat an electric shock. And after they do this 3 times, then they can expose the rat to the sound and they will freeze expecting the shock, right? So that's conditioning. And he said, okay, I wonder if there's a period during recollection when I can mess with that memory. And what he was able to find was that 3 months after testing these rats every day, they kept freezing, they had the memory, he injected the rats with a beta blocker. And a beta blocker blocks the release of a protein that is released in your brain that it is needed in order to form a memory. So if you are having experience now and I inject you with a beta blocker, you will not form the memory. And he managed to erase the memory in the rats so that he played the sound, they just went about their business. So you could imagine the implications that this would have for treatment of people who are struggling with profoundly traumatic memories, or even like the character in The Eternal Sunshine of the Spotless Mind, let me erase. But of course there are ethical problems. You don't want to erase the facts of a memory because someone might say, well, why am I alone and my children don't want to speak to me? Oh, it's because you need to know what happened up to that point that got you that point, but you want to release the person from the emotional hardship of the memory. Does that make sense? So it is my job in this film that I made called See Memory to convey what it is to remember, the changing nature of memory, and the idea of memory reconsolidation, but without using any scientific language, without using graphs or charts or diagrams or brains, but find another way to communicate that. I'm going to walk you through how I got there. So, I think the crux of it is that there is a gap, not just between the science and the public, but between knowledge and experience. And I think memory is one of the clearest examples of that. So if I asked you, whether you're working in science, the media, or the arts, to explain how memory changes over time, you might give me an explanation that's accurate, but it would rely on concepts that don't match how memory is actually experienced, and that's where the problem begins. So let's take a look. Why is it so hard to explain? So science describes memory as encoding, storage, and retrieval. But that's not really how we experience it. We experience memory as fragments, as emotion, distortion, something that appears, disappears, changes. And over time, those fragments don't stay separate. They get organized, and we begin to connect them and to interpret them and to build a story around them. And that story starts to feel like the truth. And so what fails is when we try to explain memory, as I mentioned, through diagrams, through terminology, even through traditional storytelling, something doesn't fully land. So I decided to ask a different question. Not how do we explain memory, but how do we make the experience of memory visible, which is another form of translation. So the question for me actually didn't start in film. It started much earlier in my work. I was trained as a sculptor, and I spent years working with the human figure, trying to express internal states through the body. So I have this piece that's at Vanderbilt. It's called The Fault. I was always thinking about movement, even inside the stillness of a sculpted figure. But over time, I started to, something started to shift. and memory began to enter my work. I was born and raised in Hong Kong, and I had an interesting relationship to the first 10 years of my life in Hong Kong, and then Brazil after that. And I began to just question the different kinds of memory I seem to have, you know, from the different locations that I grew up. And I really wanted to get to the bottom of why are some memories more implicit than explicit, meaning you can feel them, but you can't put them into words. Why are some blurry? Why are some in focus? Why are, you know, there's so many different qualities to a memory, and I wanted to really understand what makes them take on these different qualities. So here you can see I did this series based on my childhood in Hong Kong called Borrowed Memory. And then I did another series, you know, just of paintings based on films, but I ran into a limitation. A single image, no matter how precise the image, couldn't capture what I was trying to show because it couldn't capture change or instability or transformation. So these are exactly the qualities that define memory. So instead of asking, how do I represent memory, I started asking, can I simulate how a memory behaves? So that shift from representation to simulation is what led me to develop a visual language for this work. And what's interesting is that this turned out to line up very closely with how neuroscience understands memory, which is that memory isn't replayed, it's reconstructed. So my films see memory, the images disappear, they reappear, they dissolve, and they override each other. So I'm going to show you an excerpt. It's a 30-minute film. I believe the library has it. It's also on PBS. And it goes through a much longer arc than what I'm going to show you, but I just wanted you to get a sense of the visual language of the film. This one. Can we dim the lights just for a few minutes? Do you know what the lights are? Oh, everything's here? Oh, great. Perfect.
Memory is one of the most magical capabilities of mind. Without it, life is made up of disconnected fragments that don't have any meaning. Memory is the glue that binds our mental life together. We are what we remember. Memory is a dynamic process, and each time we retrieve a memory, it may change. So something you remember when you were little, when you remember it later, you add to your understanding of what you are remembering. People tend to be absolutely sure that their memories are the way that it happened. But memory's not a recording device, and the truth is that every time you remember, it's an act of imagination. You are imagining and reconstructing something in the moment about how it was then, and things can change along the way. Memory is visual. They're images that we add a story to. We add the drama, we add the dialogue, we add the meaning. One way to freeze a memory may be through the art of storytelling. A story gets to the essence of the emotion and revives the memory like a visit to the original event. Most of the brain's processing is unconscious and unavailable to us, and a lot of it is influencing the very little we are conscious of. There are experiences that we have that control our behavior and our connections to people. We're not usually aware of those things. We can understand them, we can learn them, we can make the unconscious conscious. Explicit memories are memories that you have a story for. You have words, you have images. The images are part of a narrative already. So it's any memory that we already have. And people generally talk about explicit memories. They don't talk about the memories that don't yet have language. Implicit memory is memory the body remembers. There are body sensations. There may be moods that wash over you. You have the feeling, but you don't know what it's connected to. Sometimes you're operating on automatic pilot. You don't really get what happened. So the trauma or the emotional response to it can happen even years later. Any two people can come together, and out of their two separate stories can create a third story that's bigger, different, not anything that either of their own stories is alone. Listening is one of the most important things we can do for each other, but listening shapes telling. The question is, how have people been listened to in the past that may get in the way of their telling their story? Somebody help me. Somebody help me. I don't want this anymore. I don't want this anymore.
Okay, let me go to lights. Oh, I did it. Okay, so that gives you a sense of the visual language that I'm using in the film. And I guess if I could just throw this out there, what do you think you understood intuitively or emotionally that would be difficult to explain directly? Yeah. Yeah. Yeah, and how it actually feels. Yeah, yeah, absolutely. Well, language can express that, right? But in a different way. But there's something about, well, what do you think helped communicate that sense of sadness or grief? Yes.
And then also I feel like the pacing of each clip and how it kind of ran, each image was run through was very slow, thoughtful. You didn't see a lot of faces until the end, and
Yeah.
so it's a lot of like shadows. The music
Yeah.
and the pacing.
Yeah, that's great. And you know, the interesting thing is I did interviews with 7 clinicians and neuroscientists, one of whom is a Nobel laureate. So I actually had a lot of scientific language in the interviews. And it was a slow process of getting rid of it and testing it before audiences. Honestly, you know, I had things like the hippocampus or the amygdala or the term, even the term reconsolidation. And we would screen it before audiences, and they would say, I'm really immersed in the visuals, and I really want to hang on to all the words because they seem really important, but I'm struggling between, like in my mind, wait, what are they saying, and what's the image? And I just kind of want to let myself go into it. And so it was not something that I could anticipate as the creator of this, but I had to get audience feedback to see how they were experiencing it. Because I was making it, and I was making every little brushstroke. You know, in the end, it's made out of 30,000 stills. I did all the interviews. I lived with the interviews, so I understood it down to my bones. And I had to really test it with audiences to get a sense of how someone who had never seen it before might experience it. So it was a process of what do we want the audience to feel? Do I want it to be an intellectual experience, in which case I could have kept some of that language in? Or do I want it to be more of an immersive experience? And the interesting thing is, I was worried that the neuroscientists were going to be annoyed that we were taking out their scientific language, but they were thrilled. And what became really fascinating to me is that they then asked if they could use it in hospitals and in neuroscience residencies as a teaching tool. And I said, why? And they said, because it actually gives you the experience of the biology of memory storage and retrieval that I can explain, but I can't give the experience. And I want them to feel it. So that was a real learning experience for me too, that I didn't realize it was an accurate rendering of the biology of memory storage and retrieval till they told me. What I did was I interviewed them and I kind of tried to take it all in. But when I'm working in my studio, I don't have a checklist where I'm like, I've got to accomplish this, this, and this. I'm absorbing the interviews. I planned out the visuals to a certain degree, but a lot of the work is quite unconscious, intentionally so. I really do believe that my subconscious is vastly more intelligent than my conscious mind, in that it has access to more things that I've learned and I'm aware of that I could possibly be conscious of in any given moment. And if I let it take over, it will have absorbed the interviews and absorbed so many things, and it kind of just comes out in the work. So, you know, I sat down with a science faculty member the other day, and she was asking me how I go about communicating it. And I don't really sit down and have a scientist say, please create this for me. I couldn't do it. If they told me that, it would be really, really boring, because I would just be illustrating their direction. And this is where I think people think artists are loosey-goosey, but I really have to ingest it, digest it, and then trust that it will come out as I'm making it. And I really have found that it works for me so there's you really have to take it all in, and then I don't think, I can't really script or plan out the biology of memory storage and retrieval in an intuitive way. It almost has to be made intuitively to feel intuitive, if that makes sense. So what's been interesting is that this isn't just an artistic experiment anymore. It's actually being used in very concrete ways, which is in medical schools, in therapy settings, and more in interdisciplinary fields and creative fields, because it allows people to feel concepts, not just understand them. Let's open up the slides. So I'm going to show you another 5-minute clip, but we're going to talk a little bit more about this. So not all memory is narrative. So in a way, storytelling is what comes later. It's how we try to make sense of something that was originally experienced without words. And that process isn't neutral. It shapes how memory is held, how the memory is held going forward. So, I want to turn this to you for a moment and just have you think about what's one idea in your work or your field that people consistently misunderstand. And if you want to just give it a thought, and if anyone wants to share what it is for them, if something comes to mind. What is one idea in your work or your field that people consistently misunderstand? Go ahead.
So I'm in the life sciences communication department, and one of the first things we learned that I think a lot of people don't know is that in science communication, if people don't really want to learn the science, it won't matter how you deliver it in a sense that isn't similar to this, but in like trying to teach science where you don't actually want to understand it is not,
So if someone's not intrinsically drawn to science,
or like willing to hear it. I think a lot of the people in STEM are like, I want to tell people this, I want to teach people it, and I think people should know it. But the issue is bridging. If people, there's a good amount of people who do, and there's another bunch of people who maybe aren't interested, and so it's trying to find the audience. And if you're trying to specifically recruit people who don't want to learn it, that requires a different approach than just saying, well, I'm going to explain it.
so what what are some approaches that you've come up with?
No. So I'm also interested in the visual communication, informal science education, and so I'm interested in these immersive experiences, less so about telling people, teaching people the content, but more so trying to engage them in just asking a question, whatever it's about, and then you can kind of sit the science.
That's interesting, because I'm not sure I 100% agree with that. I think if I would, just from my experience, having no background knowledge in this whatsoever, it has been my experience that if I were to sit down with someone and said, if I were to say to them, would you like me to explain the science of how memory is stored, reconsolidated, and potentially altered, some people would probably say, no, not really. But if I tell it to them like this, they become very intrigued by it. And I think it's because we need to communicate to people how this affects them on the most intimate level. And what I realized when I was going to these neuroscientist labs is that there's a gulf between the way the science is presented as it's researched, which is a lot of, honestly, computational analysis, numbers, but the way it actually can affect your life is incredibly powerful. And, we can't expect scientists to do it all. It's probably a different kind of brain. I think what you're saying is like the kind of person that wants to analyze it in that kind of language is not going to work for my kind of brain. Although, frankly, I do love neuroscience. But I think the reason why I love neuroscience, though, is because I understand on a cellular level that it's about me. And I think if people were to understand that this is about them, this is about their parent who might have memory loss, that this is about their sibling who might have experienced a traumatic incident, that, I think if you were to show the very intimate relationship the data has to their lives, to their everyday lives, especially with something like memory, even if you take out memory loss and trauma, you couldn't have come to class today without your memory, right? So like, you wouldn't have made it here. You wouldn't, just when you start to strip it away, you realize, I actually couldn't even tell you who I am without my memory. Because in many ways, actually in most ways, memory is actually the story we tell of how we became who we are. So it's the story we actually tell of who we are today. And I think what I'm trying to communicate that scientists have known for a long time, but the general public doesn't, is if you talk to a scientist, they will say, memory is not accurate. We know that, we've known that for a while now. And in fact, each time you recall a memory, it's almost like opening up a Google Docs file that you can edit and save. And you're not going to remember all the changes, but every time you open it, you might be tweaking it a little bit. And from a scientific point of view, a scientist who looks at this through an evolutionary lens, they say, okay, if it was meant to be an accurate recording device, it would be, right? We sort of developed to survive. So why isn't it? What is it for if it's not to record the past so that we can recall it accurately? Anyone want to speculate? If it doesn't record the past accurately and you recall it, it may have changed. There's no way of you knowing how it may have changed. Why do we need memories to change and get updated? Yes.
Just thinking about like the brain structures and emotional components that are a little bit like closer to the brain stem, a little bit more basic. So maybe the way we interpret the experience emotionally first tells us something really important about like basic survival and moving forward with that interpretation.
Right. So it's to encode a memory that might have been terrifying. So it's a protective device. And it is also, it really is not about the past. It's about helping you navigate the present. Do you see threats? Do you see, positive things? It becomes maladaptive if you're seeing threats where there are no longer threats, right? And that's where you come to a problem when memory kind of goes haywire in a situation like post-traumatic stress disorder, where your memory keeps telling you to be on high alert, but you're not in danger, right? And we can talk a little bit about the science of that and how we explore how you can update a traumatic memory. We're going to look at a different section of the film. So what every neuroscientist I spoke with, from a Nobel laureate to a new neuroscientist, said, it more even importantly than navigating the present is it helps you plan for your future. So think about your imagination. Do you think imagination is dependent on memory? How does imagination work? Can you imagine something you've never experienced, for example? Yes.
No, but I feel like you can take bits and pieces of things that you remember to create something.
Exactly. You nailed it. That's exactly what imagination is. It's putting two things that you've already recorded in a new relationship, right? Combining them in a new way. So you are creating something new by that new combination. And so that means if you haven't stored, this is why mentorship is so important. This is why role models are so important, because if you haven't seen a path, you can't really plan it or envision it. You need some kind of recording, and it could be, a mentor could be an author you read. It doesn't have to be someone you know. It could be a TED Talk you saw. It could come from many different places. It doesn't have to be someone who's you're meeting with, but that is essentially mentorship. And in fact, I met with this brilliant neuroscientist, Joachim Fuster, at the UCLA Semel Institute, who comes from Spain, and he was writing a book about his life, and he was explaining how his father had been a scientist, and his grandfather had been a scientist, and I believe even his great-grandfather, and he said, there is no way I would be. Now, he's credited, he should have won the Nobel Prize in many people's opinion, because he actually is credited with discovering working memory in primates, which is kind of incredible. So, but he himself was writing the book to say he could not have mapped out his trajectory without the examples before him. So when we say students need a mentor or a role model or a way to envision a path forward, it's neurologically true. It's not just some wishy-washy idea. We truly, that's the way our brains work. So even if you haven't had this is something else interesting. Do you think that there's a difference neurologically between an imagined experience or a lived experience? You can, it's okay if you get it wrong, if you want to just throw out. Do you think, okay, so let's try this. Oh, go ahead. No, go ahead.
No.
Excellent. Why did you come to that conclusion?
Well, considering that from my own personal experience, working about memory, thing I have felt in my body and my nervous system, the same way, like it's reacted the same way to things I've imagined, and the things that I've actually experienced, it reacts the same way.
Right. Exactly. So that's why you can watch a movie and be inspired by the movie, right? Like you can internalize. I think that's why we love these down and out to hero movies, because it actually maps out a path for us. We've all been in that position, and all of a sudden he overcame the odds, and it helps us have a vision of how to overcome the odds, right? I think that's why movies and novels and stories are so powerful, because you hear so many people say, books were my friend when I was a kid. And it's because maybe they didn't have the right parent or the right role model for who they were, but they can find it somewhere else, and they can find it in a story. So we're going to get into something, that I think is sort of simple, but also very important, which is that science explains, but art allows us to experience. And when the two come together, we don't just understand something, we actually feel it. And there are different kinds of learners. I know that's very popular in schools today. I'm a visual learner, I'm this learner. And kind of like what you were saying, you learned that if people don't want to hear about science, then forget it. Maybe they don't want to hear about it. Maybe they want to feel it. Maybe they want to experience it. So maybe you just need a different approach with those people. So I'm showing you a slide here from a new film I'm working on. And this new film is called The Memory Loophole, and it's sort of an intermediary like painting of a stop motion animation I'm creating. And what I'm trying to conjure here is this young woman, her father dies of AIDS-related suicide 4 days before her 11th birthday. And she's really haunted by him throughout her teenage years to her early 20s. And she decides to go on this trip to piece together the fragments of who he was, kind of go on a discovery trip, because he was very hidden and very secretive. And in the work, as a still image, this is only so effective. You can look at it and you can say, okay, there's kind of a ghostly presence on the chair, there's a figure walking away in the distance, but it really only comes to life when you see the dripping and the ghostly presence sort of disappearing and reappearing. So for me, this isn't enough. I need to make it move, or I can't convey the experience of what it is for her to be haunted by his presence. And here you can see sort of another image from See Memory, and we'll look at another clip. So if we want people to understand memory, not just conceptually, but experientially, we actually have to change how we communicate it. So all of this comes back to this idea that memory isn't something we store, it's something we interpret, organize, and reshape over time. And a big part of that process happens through story. So the question isn't just how memory works, but how the ways we represent it in science, in art, in storytelling, shape what we come to remember. And I have done a lot of talks also just for teachers in high school and middle school, and what I sort of explore with them is the idea that teaching and learning is the same as forming a memory. So when you form a memory, what you're doing is you're creating an association between two things. So maybe here it's the overhead lights and it's something of what I'm saying, and in your brain, you're forming a synaptic relationship between those two elements, and then when you recall it, you're recalling that network, okay? It's obviously much more complicated than just two things. And so when your professor is here talking to you, your brain is literally changing right now as we speak. You're forming new neural networks. And what we do know, as I think you mentioned, emotion is the strongest encoder of memory. So that means if you are stirred up, if something someone shares with you in class stirs up emotion in some way, you are more likely to remember that very, very strongly. And you're less likely to remember something that kind of doesn't stir up any emotion in you. So great storytellers really know how to do this. I'll give you the example of Eric Kandel, who won a Nobel Prize for his work in memory. Eric Kandel is a brilliant communicator. So he wrote this book about his own life called In Search of Memory, which weaves together the neuroscience that he discovered and his own life story. And he knows intrinsically how to stir up emotion so that we understand his journey into the science of memory through his own personal storytelling. So as I mentioned before, so sometimes we need to feel it, to see it, before we can understand something differently. And I'm just going to show you the ending of the film. So I showed you the first 5 minutes of the film, so you can actually see some of these neuroscientists speaking to you directly. So let me just scroll back a little bit. Okay. And then we'll just watch I think it's 5 or 6 minutes, and then we'll have more of a conversation, and I will try and do this.
Illumination. The science of memory is a way to shine a light in the dark corners of the mind. Speaking about memory with neuroscientists made it seem magical and hopeful, because understanding the flexibility of memory transformed memories that I saw as dark into full of possibility. It's an intellectual illumination because you gain an understanding, but with that understanding comes an emotional illumination. And I found myself thinking of feelings I had when I was a kid, when I had direct access to my imagination, which is why I've always loved Harold and the Purple Crayon, the book about the little boy who discovers he has the power to create just by drawing. The neuroscience made me realize we don't have to be victims to our difficult memories. We can change our relationship to them, and in that way, we can create the world we want to live in.
Actually, that was not the section I thought, because I'm working from half the film recording, not the full film, but that's just as well because we only have about 3 minutes left, and I would love to take questions and thoughts, reflections for a couple of minutes.